Thank you very much. I'm going to try to make a long story very short with the origin of HIV and the transmitted strain story. That need to be initiated at the beginning of the story. As you all know, HIV is the result of cross-species transmissions of viruses infecting apes in Central Africa, giving rise to HIV-1 lineage, and HIV-2, that is the result of a cross-species transmission from sooty mangabe viruses in Western Africa, giving rise to HIV-2. And for HIV-1, the puzzle is still ongoing, but we currently know that about 4 different transmission events are responsible for the different HIV-1 groups circulating. And all these transmission events has been so far identified in the south region of Cameroon, in the Congo Basin region. And these transmission events, as shown here, are responsible for the main 4 groups that we know today, the group M, the group O, group N, and the recently identified group P. And also, we don't currently have evidence of additional transmission of other SIV, CPZ, monkeys, viruses to human populations. For the HIV-2 infection, the story is quite similar. We have different transmission episodes responsible for the 9 group of HIV-2s that we know today, and moving from group A to group I that our team just recently described. And also one important thing is that among all these groups, only 2 different groups, the A and B, are responsible for the whole HIV-2 epidemic in the human population. Then showing that there is not only the strain that are transmitted that are needed, but there should be also successful spread of these viruses among the human population. Then, talking about the spread among the human population is quite interesting to observe that we now know that clearly that the origin of HIV-1 viruses, for example, the exact place of origin in the south of a country called Cameroon, which is my country. And however, the places where the epidemic of HIV-1 group M especially really set up is not the same in the same area, but is far in the south of the Congo Basin region in the current DRC, the former Zaire. Then it's quite interesting to note that not the same conditions were needed for the cross-species transmission for non-human primates to human and for the outbreak of the pandemic among the human populations. And in addition, it's also very interesting to note that even for these strains that were transmitted to the human population, the rate of transmission is not similar. We now have this network of the spread out of the different HIV-1 strains from the Congo Basin to the rest of the world, with the network including subtype B moving to USA and the Western Europe, subtype C to Asia and India, and so on. But what is very interesting is that although all the 4 groups of HIV rise out from the cross-species transmission, they do not have the same weight inside the current epidemic. The HIV-1 group M represents about 33 million HIV infections and overall about 60 million since the beginning of the pandemic. And HIV-1 group O, group N, and group P have been reported in few thousands to only few individuals to date. And you see, that indicates that in addition to the successful cross-species transmission, the spread of the viruses is not equal among the different HIV circulating. And for HIV-2, we have a report about 1 to 2 million individuals worldwide. And as I previously mentioned, only group A and B really lead the epidemic. And finally, there's also in our settings different evidences showing that some HIV strains at the group O and even group E prevalence is decreasing even without the intervention, but over time. And this was clearly shown with recent data from Cameroon. And very interesting concerning even the group M viruses is the fact that all these subtypes and recombinant forms that represent group M are not transmitted equally. since we know that for the HIV-1 group M's, we represent the major virus of the current epidemic, only one subtype represents for himself about 50% of HIV circulating, which is HIV-1 subtype C, although there are increasing evidences of other strands increasing in terms of prevalence, especially the recombinance form with the CRF02, for example, and slight evidences of decreasing of the pure subtypes as B, C, or the D. Just to illustrate, you can see here that recombinance forms, including unique and circulating recombinance forms, are currently increasing, representing major and predominant strands in major part of the world, with the leading strands being the CRF01EA and the CRF0102AG in Central and West Africa. So, another key aspect in these studies concerning HIV origin and what are the transmitted strands is the question to know, are there other strands that are transmitted in addition to what is currently known? Are there additional risks of cross-species transmission? And we know that many of the monkeys living in the Africa, in the natural areas of Africa, carry SIV infections. We have done several works in Cameroon, in DRC, for example, and identify on bushmeat markets different strands of SIV circulating among the non-human primates that are generally hunted or consumed or kept as pets by the populations. But we didn't find any evidence to date of the circulation or the presence of these other viruses in the human population. That means there are probably other factors that should be taken into consideration when dealing with the transmission and perhaps successful setup of this infection. Then among these elements are probably the host restriction factors, and we know some of them as the apopec3G that induce lethal mutations in the retroviral genome. The TRIM5 alpha protein that restricts incoming viral capsid, the tenterine that inhibits the release of the viral particle by tenting the viral particle on the cellular membrane. But to counteract these mechanisms, the viruses have developed a certain number of escaping mechanisms of adaptations to this, and most of them include accessory proteins as VPU or NEFT that are known to confer some degree of resistance to the host restriction factors as tenterine or downregulate CD4, including the adaptation of viral host of the virus to his new host. This is particularly the case of the position 30 of the GAG protein and the P17 gene. And finally, we also know that viral fitness is different between the different HIV circulating. HIV-1 is more fit than HIV-2, and within HIV-1 group M, and within HIV-1 group M is better fit than the other groups of the HIV-1 lineage. And also, to consider the fact of transmission, we should also acknowledge that the rapid evolution of HIV also plays a critical role in shaping the different population of virus transmitted and circulating. And we know that in the same individual, there are many viruses, population of virus that is called the quasi-species, and due to many elements, including the error-prone of the RT and things like that. And during the transmission, generally, it's a single unit that is transmitted to the new host, and that generates a genetic bottleneck, and that can also shape and define which is what strain will be transmitted. But in few cases, there can be multiple variants transmitted, and that can depend on the transmission route, and that the chance of having multiple variants transmitted increase as we move from heterosexual to MSM or to the injection drug users. In addition to that, other mechanisms as the co-infection or superinfection play a key role by designing the mosaic strands that we know today, including CRF and URFs. And just to illustrate that, we know that in Central Africa now, the epidemic is mainly driven by recombinant strands that are becoming the major strands in this region of the world. So we should also consider the fact that as access to treatment is increasing in many settings, the proportion of other types of viruses that are the drug-resistant strain is increasing. And we had previous data from US and Western Europe on that, but as access to treatment is increasing in resource-limited setting, the frequency of resistant viruses among population who has never been treated is increasing as well, and that drug-resistant strain, especially in the context of resource-limited settings where viral load monitoring or other biological monitoring is very limited, then these trends may represent in the future additional challenges in terms of circulating HIV variant. So to conclude, there has been significant transmission events and cross-species transmission events that gave rise to the current HIV pandemic. And not only a single strain is transmitted, but some of these transmissions has been more successful than others, and probably this is due to host and viral factors that can affect the transmission ability and the capacity to set up a successful infection and a rapid widespread among the human populations. But a very key important thing is the fact that knowing the transmitted strain is critical to design policy in terms of diagnostics, surveillance, and prevention, in terms of treatment and drug resistance and monitoring studies, as well as development of vaccine and the vaccine efficacy. And I'd like to thank my teams and thank you for your attention.